Hello and welcome. My name is Rajesh Mehta, and I'm a part of the leadership team here at Smarten. Smarten, which is powered by Elegant JBI, one of the oldest business intelligence platform built in India, which has been used by customers across the country with companies like Sharekhan, Religare, RPG, NTDB. It's listed in multiple Gartner reports, and this particular presentation is going to take you through on a small journey introducing you to assisted predictive modeling, which is a part of the augmented analytics suite that we are offering to the users. Assisted predictive modeling allows users who have no background in R or in scripting or in statistics to run complicated analytics or complicated predictive or statistical analysis on their business data to take effective decisions. So this is what it is going to be about. So I'll start off on this presentation, and there will be a video which will be either a part of this video or a separate video which will be on our website, where I will actually demonstrate using dummy data as to how effectively and simple it is to do analytics on Smarten, predictive analytics on Smarten. So this particular demonstration is focused on consumer goods and similar type of products. So the model we are going to be using would have, say, wholesaler, stockist, sales representative, staff which is on the floor of the store, or basically reaching out to end users, doing below the line activity to generate demand, and there is an expense for that, and then there are sales representatives. So that's the kind of scenario we are going to look at in this particular demonstration. So generally speaking, what we have in terms of a business is that we have data which is shown as the orange block at the bottom, and you can put assisted modeling on top of it and get insight, predictions, and suggestions out of it. And it's in cycle where the data generate. You have history of the data, and then you generate insight, and you get suggestion, and you augment the data, and this cycle kind of continues. Now, usually what's the requirement? The requirement is that there is there are data sets or data silos or databases which are in different systems or are in different formats or in, say, or different files, which need to be merged together to make sense and run the predictive analytics on. So say, and good example would be that your transaction data would be in your ERP, which would be like SAP or Navision, and or maybe some other ERP, and the rest of the stuff might be in a CRM, and there would be some data which would be in the interactive system which you have with your wholesalers and CNFs. So all this data needs to be brought in together, and you can make a kind of an analytics which would allow you to predict which component in which area. Like, say, for example, the CRM would give you product complaints, which would give you an indication of product quality and how it impacts the sales. So and you can get a weightage for that. So this is how we expect the predictive analytics to work, and this is possible in Smarten. There are two key components in Smarten which make this possible. One is the self-service data preparation, which allows you to bring in data from multiple sources, put them together, cleanse them, get it ready for analytics, and then push it simply into the assisted predictive modeling, which will select the algorithm and give you the right analysis. So without writing a single line of code. So what happens is that in a more complex environment, you may have to build different data sets for different businesses, and then you kind of bring the output from each of these data sets into a final data set on which you can run the analytics. So say, for example, manpower. You would have information about the manpower. You would like to connect it with the sales data, and you want to see as to which of the individual traits of your manpowers have an impact on the sales. So what you will get is that, say, from the manpower or the HR module, you will get factors that most impact the sales, the factors in HR that least impact the sales, and what is the volume or the quantum of sales which get impacted by each of these factors. So here's how a model would look like. Say, say we have to look at a position, and then based on that there are different parameters which come from the either the transaction system or the HR system, and you run a regression analysis on it as well as in classification, and it gives the factors which have a positive impact, factors which have a least impact, and you can get a classification based on characteristic work patterns and effectiveness to find more valued employees in the organization. So say for example, a factor with positive impact would be overall experience, and a factor with least impact would be education years. I mean, hypothetically speaking. Now once you have the output from this particular module, you can take the output and put it into you can use this effectively. I mean, that's one way. I mean, you can use it for performance enhancement, and you can kind of fine tune your recruitment policies. Meanwhile, what you can do is that you can take the 6-7 parameters which matter the most here and put it into another repository, and which can be used along with the key items from each of the modules here, like from the distribution, from the dealer performance, from the BTL, ATL, product innovation, price fluctuation, and say each of these small data sets would possibly have a few values which impact positively and few values which impact negatively, and all these parameters are put together and you can see the overall impact on sales. So generally speaking, you will have transaction patterns, payment, location, you will have sales by distribution, you will have visits, sales, collections, and you will have linked marketing data for promotion, advertising, and schemes. And you're going to use this data to kind of create an predictive analytics model. Now, if you look at the key advantage that we have here is that because of self-serve data preparation, building the core data is very easy for your technology or the IT department, and for the users to kind of create new modules and work on them, it's as easy. So it works both ways. So here are a few examples of the possibilities. So say for example, here we have taken macroeconomic data. We have taken data from the core transaction, and we have taken the retail end user data. So say industry data and the transaction data and the macroeconomic data, you can put up finding out what would be the possible growth in the business. So say when you're planning your business and you want to see whether the targets you have taken would be in alignment with the organic growth in the industry, and if the actions you are going to take will give you the incremental growth which is necessary. So say for example, if you are in the business of selling paints, you would rather look at the cement industry, link it up to the cement industry and kind of correlate it and see how the cement industry has been performing compared to your business, and draw a relationship and make a forecast for organic growth. A similar thing, you can look at the effectiveness of the sales promotion, and like the example which I explained earlier. And also you can do very ad hoc analysis, like say for example, what is the impact of wholesale price index or holidays on end user participation in BTL activity. So there is a good chance that as the prices of consumer products goes up, the participation in the promotion activity increases, because people are not willing to spend money and rather do and look at a promotion activity. You can also do an analysis of how an advertising campaign or any of the other macroeconomic factors have impacted your business. So this is how it looks like. I mean, it is you can take a decision which is at a micro level, which is like a regional sales manager taking a predictive modeling, to a decision which would be taken by the CEO. You can make plans based on the predictive model, and short-term as well as long-term plans, and then you can connect this to macroeconomic data to kind of validate it also if required. So that's the three blocks which make up the whole thing. So now this is how the interface looks. The forecasting, classification, clustering, correlation, regression, frequent pattern mining, and hypothesis testing. These are the built-in algorithms which are there in our system. And assisted predictive modeling automatically detects the moment you select this and push the data onto it, it will select the right algorithm and kind of give you results based on that. So you will have three possible ways of getting around it. One is that you will have a reusable standard predictive model for safe, looking at how the market is going to be in the coming month or so. You will have another model for taking a decision, which would be like, say, I have got about 100,000 to spend on my customers. Which customers should I spend these on? That would be an assisted model for day-to-day decision taking. Or then it would have a model for strategic decision taking, which maybe you could run it a year or once a year or twice a year. It includes everybody. It includes the technology team who builds the data. It includes the business analysts and the technology team where basically they can put in the models together. And assisted predictive modeling works with the end users. The data can be built by the end users. So here's a example of a predictive for sales scheme. You get your transaction data, you have a past scheme data. Scheme would be an kind of a promotion or a proposal to your customer, which basically has an incentive to buy more. The parameters for there, the expense for advertisement. You run a regression analysis and you can get a sense of the sales which is expected, focus which is required for different regions, and the parameters which will have an highest impact, and what would be the cost of the ETL, BTL. So this is the kind of model which can be generated and run regularly. And this is then we can have a model for planning. Okay, so basically, you can have the credit note, discounts, macroeconomic data, combine it, run a regression, and you can do a trend and a forecast. You can get the focus areas, you can get the macro data which it will connect to, and the performing parameters. You can also do hypothesis tests, whether it is the people which are effective or say the sales scheme which are more effective, what matters the most. So what new product and effective launch parameters. So if you're launching a new product, which are the parameters which have the most effectiveness in getting the salesperson as well as the retail end of the spectrum to be active, and what type of spend or what type of people should be activated to kind of focus on getting things done. So same thing for targeting on specific areas. So this kind of brings us to the end of the presentation, and what we will do now is that we will kind of have a look at the demo of the product, and I will show you a couple of very good examples of how you can put this to use in your life. Thank you. Okay, so we're now going to do a demonstration. So this video recording is a part of the presentation which we are building on predictive analytics. So you may be seeing this in continuation with a presentation or something else which might have been before this video. One quick word about Smarten. Smarten is an analytics platform which has been used around the world with a number of customers here in India, and it's basically listed in multiple Gartner reports, and it's got unique modules which make it in the league of best of the analytics platform. It includes self-service data preparation, smart visualization as well as assisted predictive modeling. And this video is going to be about assisted predictive modeling. And what we're going to do is that we're going to look at the consumer industry data and try to make predictive analytics based on this. So I just log in as the first step, and the first step you do is connect to the data. So we got our files in text, so I'm going to call it consumer sales WSS data on say November. All right, and now I'm going to pick the file up, and so I've got a data state-wise with wholesale stockists and below the line promotion expense. So I'm picking up this data. It identifies what is the separator and kind of gets it ready. This name is the name of the data source, so I connect with it and it gives me a snapshot of some part of the data which is available, and I say okay, and it asks me whether I want to make a data set from this source, and I say yes, and I call it consumer underscore products data WSS BTL November. And I can put in a description here if I have to kind of, if I'm going to use similar names, and later on I have to check as to what this name indicated. I'm not doing this at the moment. So this is the data source we created, and I say okay. These are the different fields which are there. We have got number of things which we have already put together, and I've selected all the fields and I have brought it into a data set. So while the data extraction is in progress, what I'm going to tell you is what the data set comprises of. So it's got a year, so there are multiple, I think it's covered about 5 years data. There is a state. We got the actual rainfall for this state for that year. We got the GDP of that state. We obviously have the population and hence the per capita GDP. We got, okay, so the extraction is complete. So it just was asking me whether we would like to upload that data. So we have said okay. So here this population, then WSS universe stands for the wholesale stockist universe, which would mean that in this particular state the number of wholesale stockists possible are 12, and what are the actual? About 1. And what's the gap? The difference between 2 is 11. Salesperson required is actually nil, but you actually have 1 salesperson in case of Mizoram, and so hence the vacancy is -1, but in some cases you can land up with a high vacancy of 25. Sales promoter is a person who actually does promotion activities on the ground, which tantamounts to below the line expense, sales expense. We got a number for that, and we basically can have an indication of the BTL expense, which would be actual for that state for that particular year. And based on the data which is available, there is sales in rupees and crores. Okay, so the only thing which I'm going to there are enormous number of possibilities in cleansing and setting up this data and making it more attractive and making it look fine. And I'm just going to quickly tell you that you have everything available on right click. You can mix, merge, change data, do whatever you can possibly do in Excel or what, irrespective of the tool you are using, you can get it done here. But this part of the demonstration is not about that. There are other videos which are available on our website where you can look at how a self-service data preparation tool can help the technology department as well as end users. So here we just got to do one simple thing. We're going to change this dimension, and we're gonna change it to date. Okay, so what we gonna do is that we're gonna take this column and we're gonna mark this as a time dimension with a year. Okay, so once this is done, we say save, and then I'm going to publish it. It will ask whether I want to do a real-time data set or a cache data set, and I say I'll do a cache data set, and then we say publish. Do you want the default basically data set? Yeah, we don't want to change it. No, so that's it. So it's published and ready. So we just save this, and now what we are going to do now, we want to see which of the factors impact the sales, and we just want to run a few analysis based on these various factors. But just as a thought which came to me just now, I'm going to add one more thing to this. Okay, so I'm just going to complicate this a bit. I'm going to bring in another data set. Okay, sorry, so let me see if that data set is available here, and if it is, I'm going to pick it up. So let me see if yes, so there is a demo data set for cement which had been built earlier for different states, which is available. So I'm going to select this. Okay, but that has got, all right, it has got year, it has got state, and it's got million metric tons of sales of cement there. All right, so that's wonderful. So we have got this data set. So maybe, I mean, we would like to connect our sales with the sales of cement, and also look at the possible way we can analyze how we are performing with different levels of effectiveness in wholesale stockist or the population and things like that. So I'm going to join these two data sets. So there is a very simple thing to do. You just say blend, and you select the data set. Okay, and because this is not so complicated, in the sense that there are usually you have a unique key, a primary key, or it will find out which of the fields are common, and in this particular case the year and the state are common, and they will be directly linked to the data set which has got the wholesale stockist and the BTL sales. So I'm going to apply this. All right, so we have this data set ready. So the data set we are going to use for our analysis now is consumer products data wholesale stockist BTL November. All right, I published this and we are ready. Okay, so now let's do what is called the Smarten Insight. Smarten Insight is also assisted predictive modeling, since I've been using that terminology a lot in my earlier presentation and in this demonstration also. Smarten Insight is your insight into your business using assisted predictive modeling. So these are the different categories of algorithms which are available for running the predictive analytics. So forecasting, classification, clustering, correlation, regression, frequent pattern mining, and hypothesis testing. We can do a couple of these with our data sets, and it is going to select. There are, I think, about quite a few algorithms. I think around 45 algorithms which are already built in, and we are building more as we go along. But we have built the range which takes care of most of the business needs in terms of predictive analytics. So what we're going to do here is that we're going to select the method we're going to do for our data set. Now I've chosen regression, and I'm going to select the consumer product data set and say next. Okay, so first is the target variable. So what we're going to target? So we're going to target the sales in rupees and crores, and what we want to check as the first step is how the vacancy of a sales representative, a vacancy in a promoter, a sales promotion, and BTL expense impact the sales. So this is the first test we're going to run. So we're going to find out as to how these have an impact, and I'm going to run this. It's going to select an algorithm on its own, and it will give me a result. So here we have the result. So it says that R square is 0.849, and it is indicated with a smiley that, oh, well, I mean, you're good. The data seems to be ready for analysis, and you know what we are getting in terms of results is good. So the variables have significant impact on sales are vacancy, promotion, manpower gap. So all three variables have got an impact. So a single unit decrease in vacancy, so 1 minus, will result in an 18 crore rupees gap in sales. Promotion gap, a 9 crore rupees sale. And BTL expense, 1 crore less, would impact 46 crores of rupees. So that kind of gives an idea as to how the overall picture for across the different states is. Now you can filter this down to a single state and get it narrowed down as to how different it is in different states, but this is the overall view of the country for various states. So as I close this, you have this model. You can look at it graphically. You can see based on different parameters as to how it impacts, and I can do a test here. So I can say that, you know, say for example, my vacancy gap is 0, my manpower is surplus, and I do a proper BTL expense of 4 crores, what's going to happen to the overall sale? So this is going to increase up to 157 crores. So that's the way this model would work. And now I want to change this. So now I say that I want to remove this. I want to find out if the GDP in crores and GDP in capita have got an impact on my sales. So here it is. Yeah, the answer obviously is yes, and it has a very direct impact on sales. And we can see that you know, and single unit increase in GDP in crores would result in a unit sale of 44 crores. So that's interesting. That's interesting. So a single unit increase per capita would increase in 7 crores. So this would be in, yeah, this would be in a larger unit, and it will be in thousands of crores. So I mean, it does look big there. So this is the other set you can do. Now let's look at something else. So say generally we land up saying that the rainfall has an impact on sales. Okay, so I'm going to do rainfall and check whether it has an impact on sales. They do not have a significant impact on sales. Well, that's it. So I mean, the theory usually is that if there is a good rainfall, the sales takes off, but doesn't seem to be the case. Okay, so these are the different kind of hypotheses which we are running on regression here. So now let's remove rainfall. Let's put the wholesale stockist gap. Let's keep the vacancy gap. Let's keep the BTL expense in crore. Let's keep the BTL expense and the wholesale stockist in, and let's also bring in the state and make an analysis here. So wholesale stockist and BTL expense have got an impact. The state obviously doesn't have a direct impact. So what is the impact? a unit change in wholesale stockist will result in a decline of 16 crores of sale. We're talking about per state stockist across the board. So, huge impact. Every place where you miss out on a stockist, there's going to be a significant impact in sales. A single unit increase in BTL sale spend would increase the sales by 49 crores. So we want to test this. So I select, say, okay, so it's not picking up the state, so let me just check. Okay, so there is some challenge there which I am not able to figure out, so let me look at it once again. Okay, here it is. I have to go and thank the technical team for not embarrassing me. Okay, so state Maharashtra wholesale stockist gap, we say, is about 20, and BDL expenses say 1, and the impact is 45 crores. So this is the way you can kind of use this model. Now, so this is some part of what you can do with assisted predictive modeling. We can do much more, and there are more videos we are doing in this series which you can continue to look at. And there is a video which I'm going to continue for this presentation after taking a small break, so that it can be published independently also. Will be about classifying manpower and to find out what is the most effective skill or an effective parameter a person has to increase the sales. Okay, thanks. Okay, welcome. If you're seeing this in continuation with the other videos, welcome back. If you're joining us for the first time in an independent video, Smarten is a business intelligence platform, and I invite you to look at the diverse functionality which are pretty unique in the world of analytics and predictive analytics, which we have demonstrated in the other videos. You can download a couple of presentations. So what you can see on this screen are the couple of key features which make up augmented analytics. One is the self-serve data preparation, and the other is assisted predictive modeling, and the other is smart visualization. Assisted predictive modeling allows you to kind of build a business data model and run predictive analytics without writing a single line of script, and that's what we are going to do now. So if you want to see how data preparation is done, there are a couple of other videos which you can have a look at, but right now we're going to just dive right into a data set which we have prepared, and here we are going to look at the effectiveness of a salesperson based on some data in the person's business as well as in his life. So on the left hand side is a list of names, then we have the years of education after the 12th grade, and then years with the company, the number of wholesale stockists or the outlets which the representative is handling, the sales in different years in value, the average sales, the compounded annual growth rate, which is a compounded annual growth rate over a period from 2013 to 17, the average sales. Alright, this is not average sales, this is something else. We can remove this. Now we can kind of delete remove this column. Okay, so I've removed that column. I think it was something which was not required, and okay, so this basically makes up the data set which we are going to use for our analysis. So one can publish this, and it's ready to go after that. Now Let's take a Smarten insight. So a new Smarten insight. So now what we want to do is that we want to find out how one variable, which is mainly going to be sales, impacts the other variables to make what type of an individual is effective. So I mean, the effectiveness of the salesperson will be determined by, say, the compounded annual growth rate. I think compounded annual growth rate is far important than the total sales, because I mean the total sales depends on multiple variables. I mean, including the region and including the market type. So we look at years of education, years with the company. We don't look at number of wholesale stockists entered. We look at we look at the say the wholesale stockist handler also, and we run the regression analysis throughout the data set. So this is the output. So it says that following variables have an impact: years with the company, and following variables do not have an impact: education and the number of stockists handled. So this kind of gives you an idea that what makes an bigger impact on compounded annual growth rate. So the growth rate is more or less dependent on the years with the company, and retaining employees makes a big difference. So just want to change this analysis a bit. So I'll remove this wholesale stockist and I will again run this. So I've removed the number of wholesale stockists, and this says that again years with the company matters, and years of education after this thing after the school, that means after 12th grade, does not matter at all. So let me modify this further. So now we are clear about one thing, is that the education doesn't matter. So we'll bring in the wholesale stockist once again. One good indicator would have been the salary, which is not there in this data set. Same thing again. So it doesn't matter what how much wholesale stockist he handles. But to change this dramatically, say for example, if I say that I want to see the average sales, then both the factors have a very significant impact: the number of years with the company as well as the wholesale stockist. So it kind of gives you a very different dimension. So compounded annual growth rate gives the effectiveness of a person over a certain period, and that is only dependent on years the person has spent in the organization. Doesn't depend on the number of stockists he's handling, doesn't depend on anything else. But the average sales, which is like the total sales he does across wholesale stockists, depends on multiple factors, including the number of stockists he is handling. But one thing that definitely doesn't matter in this particular data set is the number of years the person has spent in education. Rather interesting. All right, thank you.